The title of my talk is PCF, a non-technical primer. It's actually a pretty short talk, and it's very non-technical. Let me give you a bit of background about why I'm giving this talk in the first place. So it sort of started, I guess there's a bigger theme and there's a smaller theme. The bigger theme is just generally how fast this company's grown and how many different things we're all doing. And it's kind of hard for different parts of the organization to still be in touch with what everybody else is doing. But we're all part of the same company, sort of selling the same thing, labs and PCF and data, they all kind of go hand in hand. So there's sort of that general theme of like, we need some stuff to keep the things glued together. And specifically, so I PM a few teams, one of which is in LA, and I was visiting them one time, and I happened to overhear just another conversation from some labs pivots, and I could hear that they were, I'm going to anonymize things, but they were a client for company X, and they're using some technology Y, and my question was, why? Well, why? Why are you using this technology Y? We have PCF. And so we chatted a fair bit. I talked to the clients and I talked with the pivots. And one of the themes that sort of came up was a lot of people in labs don't necessarily want to know more about PCF, but don't necessarily know enough about PCF and all these terms, PCF, PWS, PES, SaaS, IaaS, VMs, Docker, what are all these things? In addition to there are a lot of engineers who don't know this stuff, even though PCF is sort of directed towards engineers. But then also designers and PMs who probably don't as directly use PCF, they're even less likely to know what these things are. And so it puts labs often in a difficult position of, unless you have somebody on the team that has that expertise, not sort of being able to talk to the client about what is PCF, what are these things that we sell, and it can be, that sort of sales play becomes a little difficult. So this talk is sort of just a non-technical introduction to bridge that gap and sort of a jumping off point that should make it easier to then dig deeper and learn even more. So that's the goal. I'm just going to start out by defining a bunch of terms, and that's almost all of what I'm going to do. It's a very short, simple talk. What is the cloud? The cloud is just other people's computers. Usually those people are like Google or Amazon, so not like my mom and dad's computers, but it's just someone else's computers and you're doing stuff on them. So you'll hear terms like cloud compute. Cloud compute just means running programs on other people's computers. You're using the compute resources, the CPU and the memory to run programs. A lot of the times those programs will be a web app, but it could be whatever, right? DNA sequencing, could be anything. Another term you'll hear sort of hand in hand with that is cloud storage. And this is just saving data on other people's computers. So like Dropbox, right? Or Google Cloud Storage or Apple Cloud. Commodity hardware. So commodity hardware is another term you might hear. And the concept there is just that big, powerful computers are cheap these days. This sort of economy of scale sort of thing is possible now, and it's what allows cloud computing and cloud storage to be a reasonable, feasible thing to do. These big companies are able to have these massive data centers and then sell chunks of compute resources and storage resources to people like us. And usually the unit of that compute resource is a virtual machine. So what is a virtual machine, or a VM for short? A VM is just a program that simulates a real computer. That's really all it is. So you have these big, beefy commodity hardware machines that are too much for what you need to do. If you're running a Spring app or a Rails app, you don't need 128 gigabyte memory, server blade. You need a little piece of it. So there's a little program, there's many little programs running on that big machine, and each of those little programs is like a little machine, and you just get that little virtual machine. You'll hear container as well. you'll hear virtual machines and containers, and if you're in this space a little bit, you'll hear virtual machines versus containers. It's now a war. A container is also a program that simulates a real computer. There are many more nuances to it than that, but not that big of a deal. At the end of the day, that's kind of all it is. So this just means, anything as a service just means you pay someone, they bill you monthly, and you just get what you ask for, right? Rather than you own it, you get it sort of as a service, monthly or annually or whatever. So infrastructure as a service is usually about getting on-demand virtual machines. So you can say, hey, AWS is Amazon Web Services. Hey, AWS, give me a few thousand virtual machines for the month so I can sequence some DNA. Or GCP, Google Cloud Platform. So you might have heard recent announcements about PCF, Pivotal Cloud Foundry, now being on Google Cloud Platform. And so there's actually all these different companies and providers offering this infrastructure as a service. So people have their choice of whether they want to run their virtual machines on DigitalOcean or on their own servers or on AWS or Google Cloud or what have you, right? Software as a service. This little picture sums it up pretty accurately. Software, used to get software as a product, right? A little CD. Now you get software, you don't get it, you just pay for it, when you use it. Or you don't pay for it, depending on what it is. So if this concept, like if you're going to get one concept, this is probably the most important concept to get, software as a service, right? This is the most important change that's happened in the last 10 or so years, and it's kind of like, everything we do here at Pivotal, we're building software for the cloud. Back in the day, there was no cloud, there wasn't as big of a thing, right? So the examples I like to give are things like Wikipedia. So you guys might remember, I always remember this fondly, doing homework assignments with Microsoft and Carta, right? You get a CD, you stick it in. It wasn't very interactive. There was I remember there was 2 interactive things. You could build fractals, and you could figure out your daily nutrition stuff, and that was about it. And it was in Carta 95. And then when 1996 rolled around and you have to do any sort of project on some new recent events, you have to go and buy a new CD from Walmart or whatever. So you used to get software as a product, right? Another example is TurboTax. So you used to get TurboTax as a CD. Now you go to turbotax.com and you pay once a year, right? And by being on the internet, that enables so many things. So for instance, because TurboTax is on the web, it can have a bunch of your information in the database. It can pull a bunch of stuff from your banks and all that kind of thing. So the next time you go to fill out your taxes, half the stuff is already filled in, right? So by being connected to the web, that enables a lot more. It also creates more problems in other ways, but it enables a lot more. There's other sorts of software as a service that wasn't even fathomable back then. So if you think of things like social networks, there's no such thing as a social network on a CD disconnected from the internet, right? You would just have imaginary friends, Microsoft Bob or something like that. All right, so what is PaaS, Platform as a Service? Platform as a Service is, I briefly touched on it in the previous slide. By switching to this software as a service model, there's a lot of benefits that you get. As a user, you always have the latest stuff because it's just updated by whoever's providing it to you. You don't have to buy the latest thing, right? You can pay as you use it. As the person building that software, there's a lot of challenges now because I need to build that. Remember, when you're building a CD, it needs to work for one person at a time. So if you're thinking about performance issues, it needs to be able to put on a CD, plugged into the computer, and for that one person with that one keyboard to do it. But now, if you have a website that's on the web, millions of people might be accessing it at the same time, right? So that's an entirely new set of problems. you now need to like get it running on the web and accessible via the internet. Like you can't, instead of just shipping around a CD where you kind of know what it's going to do, people have all these different browsers and they're looking it up on mobile devices and they may or may not be connected to the internet. So a whole set of new problems sort of arises with software as a service on the web. Platform as a service is this idea of a lot of those problems that you need to solve when you're building software as a service are the same problems everyone is solving, right? As every industry moves towards software, right? Instead of Blockbuster, you have Netflix, Instead of what was that old travel agency called? Like some guy's name, Thomas Hancock or something. You now have Airbnb and Kayak and those sorts of things, right? Every industry is basically now on the web. So everybody's kind of solving the same problems. How do I take my Spring app and run it somewhere? And the idea of PaaS is to solve a lot of those problems for you so that every single organization in the world doesn't have to reinvent the wheel around how to solve these problems. So there are problems. Yep, and I'll get to them later. I'll sort of dive into what I just dived into now in a bit more detail a little bit later. So you may have all heard of ANSY's Haiku. Here's my source code, run it on the cloud for me, I do not care how. That's the kind of gist of what I just said, right? I build my app, whether it's TurboTax or Wikipedia or Netflix. It's a bit of a oversimplification, but I build my app, here's the code for it, I want it to run somewhere. I don't care about all the other problems that need to be solved. They're not as interesting. So what is Cloud Foundry? Right, now let's talk about some specifics here. So Cloud Foundry is a platform as a service. It takes lots of code from developers and it runs those code as applications in containers. That's the gist of it. By the way, feel free to interrupt with questions. I meant to say that earlier, but feel free to interrupt with questions in the middle. Now there's a bunch of different ways you can get your hands on Cloud Foundry. One of these ways is open source Cloud Foundry. OSS stands for open source software. And this is just the source code for the platform itself. So this is the source code itself. You would need to figure out how to then actually get it running somewhere so that you can use it and keeping it up to date and figuring out all the best practices around it and what happens when something goes really wrong, like who are you going to, are you going to have any support for that? Not if you're just using the open source stuff, right? So it's free, so there's pros and cons to it, and if you have a lot of operations skills in your organization, you might be able to get people to maintain an open source Cloud Foundry for you, like our Cloud Ops team of experts who run Pivotal Web Services for us. But it's not necessarily for the faint of heart if you want to run a full production Cloud Foundry. Running a full production anything is not for the faint of heart. The CFF is the Cloud Foundry Foundation. So this is an independent governing body for the open source Cloud Foundry project. Cloud Foundry, the project itself has had an interesting history in terms of IP, intellectual property. Currently, it is IP of an independent, it's not Pivotal's IP. It is technically the Linux Foundation's IP. Under the Cloud Foundry Foundation is part of the Linux Foundation, and so they sort of govern the IP of the source code, as well as the most important thing about the Cloud Foundry Foundation is that it's a foundation consisting of different contributing members. So governance in the Cloud Foundry Foundation is dictated by commits. Whoever commits the most gets the most say. And so Pivotal commits the most, but IBM also commits heavily, GE, HP, SAP, Fujitsu, the list goes on. And so all these big companies, it's actually a really interesting thing, all these big companies are committing to it because obviously they want to make money off it, so they're at the same time contributing and collaborating on the same code while competing with each other and trying to differentiate from one another in terms of how do we take this code and do things to it and put stuff onto it and sell it and actually make money off it. So there's a whole interesting thing going on there, but I won't dive too much more into that. So what about Pivotal-specific versions of Cloud Foundry? There's Pivotal Web Services. That's probably the simplest place to get started, if you will. So this is Pivotal's hosted Cloud Foundry offering. It's similar to Heroku, which I imagine a lot of people are familiar with. So it's a true platform as a service. You go to run.pivotal. Well, let me just go to the next slide. So individual developers or teams can sign up for an account. So you just sign up and you're good to go. You pay for usage, and the platform itself is hosted by Pivotal, so you don't have to worry about running Cloud Foundry itself. You worry about your apps that are on Cloud Foundry, but you don't have to worry about maintaining the platform itself. That's part of what you pay for. So your experience as a development team, maybe as a client team working with or as a labs team working with a client, is you push your code and PWS runs your app, and that's it. And then customers will be able to reach your app at your app, whatever you call it, .cfapps.io. So that's Pivotal Web Services, PWS. Then you'll hear about PCF. PCF is kind of a term that means many things, unfortunately. So PCF, Pivotal Cloud Foundry, it can refer to, sometimes it just generally refers to everything Pivotal sells that is Cloud Foundry related, right? But can also refer to just, there's more than just Cloud Foundry, right? There's all these different services and nice GUIs and other sort of tools that sort of are attached to the Cloud Foundry ecosystem. But the core platform itself, that's often also referred to as PCF. And PCF is the Pivotal-supported Cloud Foundry distribution, usually deployed on-prem. And on-prem means on the customer's data center. So rather than it being in a public cloud like AWS or Google Cloud Platform, it's in a private cloud, which is like their own cloud running on their own servers. So they still want this concept of virtualization, VMs, and on-demand access to compute resources, but all the hardware, all the big commodity hardware, they want to keep it in-house for cost reasons or compliance reasons, security reasons, what have you. So on-prem is usually how we sell PCF. PCF is usually for large enterprises, and they pay for the PCF suite of products, so the core PCF platform, as well as other sort of services that go along with it. Again, you pay for usage, like you do with PWS, and also support. So Pivotal enables operators within the enterprise org to host PCF themselves. So this is a little different than PWS in that with PWS, Pivotal is hosting it for you somewhere, technically on AWS. In this case, Pivotal gives you this sort of easier to run solution that takes Cloud Foundry and lets you configure it to run it on your own data center. So you typically, if you're part of this large organization, you might have a team responsible for operating Cloud Foundry for the rest of the thousands of developers in your organization. For context, when I say large enterprises, I mean like companies that have literally tens of thousands of engineers developing applications. It's kind of crazy to think about that, I don't want to name customers again, obviously, but some of our biggest customers that you don't think of as software shops have massive, massive amounts of engineers. I don't even know what they do with them, but they have them. So again, the experience is the same though for the developers. For those 10,000 developers that they have, their devs push the code and PCF runs their apps for them. The enterprise is then able to choose how internal users or external customers reach the app. So your app your specific enterprise domain, and you can choose. They might be building a lot of internal facing apps or external end user facing apps. Another thing I wanted to mention here, this other note, customers are also entitled to put AI usage on PWS. AI is a term I didn't define. It means application instance. So when you push your app, it runs in a bunch of containers, these little machines that are just running your app, and every little tiny machine that's running one copy of your application is an application instance. So customers who are buying PCF are also able to put some of that stuff towards PWS, and that's referred to as PWS-E, PWS entitlement. So all that means is if you've paid for PCF, because that's what we want customers to do, but for whatever reason, there's some cases where you still want to put stuff on PWS, maybe just for development purposes or whatever reason, you're able to. We don't make you pay extra for that. PCF Dev. So PCF Dev is just PCF running in a single VM on your laptop. So just as these big commodity pieces of hardware can run these little virtual machines, so can your laptop, depending on your laptop. But if you have, like this one can, my MacBook Air can't. But if you have a somewhat reasonably sized laptop, you can run a virtual machine, and that virtual machine can run all of PCF in it. So the whole platform is running in a tiny machine on your machine. And you can push apps to that, and you can look at those apps. So individual developers or teams can just go download it. It's free, so there's no pay for usage type of thing. It's a single command using a tool called Vagrant that just brings up this whole PCF experience on your laptop. Same experience for the developer. You push your code and you see your apps. The one little difference here is only you can reach it at whatever your app is, .local.pcf.io. So you can't try to build your little startup and have it running on PCF Dev unless you allow everybody to sort of access your computer and mess with DNS. And I'm getting too much in the weeds already, so never mind that. You don't try to do that. So one nice use case for this is if you want to just start kicking the tires, going back to the original theme of the talk, if you're someone in labs and you want to be able to talk to customers confidently about PCF and you want to start by tinkering and using it yourself, PCF Dev is a great way to start. It's also a really nice way to, if you're working with a customer who's using PCF for their real deployments or PDubs, and you want a nice sort of development flow where you kind of, you run your server locally on your desktop, on your computer, and then you want to see what is it actually going to look like when I push it to PDubs or push it to PCF. Well, just push it to PCF Dev first, see it work on your laptop, and then you have a lot more confidence that when you push it to PCF in the real PCF, it'll work. So, going back to the problems I mentioned earlier, remember I talked about software as a service. It's what we're all building, and it's great, except it makes lots of other things hard, or it introduces new problems that everybody will need to solve, and that's the whole point of a platform. So what are those problems, and how does Cloud Foundry solve them? So one of these things is logging. Logging, this is kind of back into the territory of here's a bunch of terms you'll probably hear, and it'll be good to know about. So logging just means you've got an app running, and when it's going well, that's great, but when it's not working, it'd be nice to know what's not working. And most frameworks allow you to sort of have logging all throughout your application so that whenever you do anything, it'll write some messages to an output stream. So it's all great that it's writing those messages to some output stream inside some isolated container somewhere, but how do you actually see those? Getting the logs from all your applications to you as a developer or an operator is non-trivial, especially if you're building this, if you're following the microservices approach and you have a ton of different microservices all over the place, and you're part of this really large enterprise, and so you have tens of thousands of developers all doing this thing. You kind of want a unified solution for all this. You don't want everybody reinventing the wheel. How do you do this? So the nice thing with Cloud Foundry is you just do CF logs. CF logs, my app. And you see this stream of logs coming out of your app. And that's all it is. Metrics. So like I said, logging is a text-based live stream of what your app is doing. Metrics is a number-based live stream of what your app is doing. So you can get these metrics out of PCF and get some nice charts. What does my request latency look like and stuff like that, right? Why are all my requests sort of taking so much longer now? You can start to debug those sorts of issues. Right, a lot of this stuff is geared around a lot of the themes sort of underlying Cloud Foundry, and one of the things that differentiates it too from a lot of the other things in the space is it takes these sort of day two concepts as a first class problem. So not just how do I get my thing up and running, but once it's up and running and in production and real people are using it and stuff is on fire, how do I actually then deal with those problems? So getting logging and metrics as sort of a first class thing is one of these things that PCF gives you. The ability to scale out. So the term scaling out means just running more identical copies of your app program. Right? Let's say your app can only handle 300 requests at a time, and then it runs out of recent memory or something, right? Well, what happens when you're getting 900 requests? Well, you want 3 copies of this thing running. So with Cloud Foundry, it's easy. CF scale my app -- instances 3, and now you have 3 copies running, and it's just that easy. Scaling up. So maybe you don't want more redundant copies of the same app. You just want that one container, but make it more beefy. Just give it more memory or more CPU or more disk for whatever reason. So again, CF scale my app -- memory 20 gigs, something like that. Routing, right? It's I was at a conference a few weeks ago, and somebody was demoing yet another container scheduling thing. And he mentioned like all these container schedulers, they do these demos and then they stop when it comes to actually figuring out how to get traffic to the app, because that's, a lot of these things are much more bare bones that are out there. With Cloud Foundry, getting traffic to your app again is a first class thing. So there's a dynamic routing tier, and it handles all the routing. So it's easy to get mydomain.ca traffic to all your app copies, or myapp.cfapps.io routed and load balanced across all your different copies of your application. And it'll even know that, oh, this instance of my application is crapping out right now for whatever reason. It's crashing. It won't send requests to there. It'll just be smart and send them to the other things. And you get that for free. Services. So it's all well and good to just have a sort of stateless Spring app or Rails app that serves some static web page. But in real life, you need many other components to make a real application. You probably need a database, or if not, you need a message queue, or also some way to aggregate all your logs. So it's going back to the logging question. Oh yeah, go ahead. How do customers pay for services? So I think with on PWS, there's a marketplace. So you can do, if you target PWs, you can do CF Marketplace, and it'll show you all the services that are there. And then you can take one of the services like ClearDB, which is a MySQL service, and it'll have a bunch of plans. So there might be a free plan, and then a plan that's like X dollars per month for so many gigs of storage in your database, and so on and so forth. With PCF, I think I actually don't know the details. There's a very large catalog of services, MySQL, Cassandra, Redis, Rabbit, blah, 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 blah. And so they all have their own SKUs. I don't know at the fine level of detail, do they just pay for it as a whole thing, or do they pay for every instance of the service that they create? That detail I don't know, unfortunately. But yeah, so if you're an application developer, you need these things, and Cloud Foundry makes it really easy to connect this to your application. So you say CF create service, MySQL something, blah, CF bind service, MySQL, my app. So you just bind the service to your application, and that unified service broker model of connecting applications to services is uniform across all the different types of services and all the different applications. And the actual, there's something called the Cloud Native Container Foundation, and they're actually adopting our service broker model as a sort of a generic model for attaching services to containers. So they've seen the thing we built, and they liked it, and they want to make that the standard for containers and services. Security, the 3 R's. This is another really, really big one. Again, it's all well and good to like start up your Docker container, if you know what Docker is. But in the real world, it's a lot harder than just, I made a container and now it's running. What happens when something in that container, you know, you all might have heard of Heartbleed. That was a famous OpenSSL vulnerability that happened not too long ago. So what happens when there's a vulnerability, a really major security vulnerability in some library or module in your container that you don't actually really care about? It's just something that like you need to have. And then always think about questions like that, and then think about them at like an absurdly high scale. What happens when you have to solve that problem for tens of thousands of different developers at the same time? Are they all going to have to figure out what the problem is, figure out how to fix it, and then all individually like rebuild whatever Docker container that they're trying to build and re-push it through the CI? Or would it be nice if the platform just swept through the entire platform for you and just fixed things? So I highly recommend everybody check out Justin Smith's talk or blog post and or talk on the 3 R's, rotate, repair, repave. Basically talking about how security in large enterprises is really hard, and Cloud Foundry and underlying stuff such as Bosch, which we use to deploy Cloud Foundry, really makes it easy and automated to just like roll through these problems when they exist and sort of fix them automatically. Right? That's kind of a big piece that's missing right now in this whole new way of building software. But it's something Pivotal kind of does front and center. Yeah.
Do containers ever get reused? Like if I start an app and then spin it down and then Mikey wants to deploy an app, does he then have the possibility of seeing my code and the keys and all that stuff?
So sorry, could you say that one more time?
I push an app, it's up for 6 months, I spin it down, none of those containers are freed up, I guess.
Mm-hmm.
Could Mikey potentially get that as he spins up another app or something? Would he get?
No. So the way, so the question was, do the containers ever get reused? And I think that what you mean there is like, imagine that there's like a container sitting out there that like they put Will's code in there for 6 months, and then Will doesn't like that code anymore, so he goes away, and then Mikey puts his code in there. That's not how it works. It's never, the whole container gets deleted. Right? Like even, in fact, your container in reality probably only lives for at most a week. Right? If you're on something like PWS, where we're upgrading the platform constantly, you never notice. With zero downtime, we will take that container, start a copy somewhere else, and delete this whole machine and bring up a new one, because we're upgrading everything on the machines constantly. Right? And so it's just this seamless upgrade thing, but you don't notice because we start up a new one before we take this one down. So your customers are still able to get to your app, but there's no such thing as like a container that gets reused. Yeah. Yeah.
Does that mean I need to keep on top of updates to the platform so that I'm updating my app before you upgrade my container?
Say that one more time.
Say I've got my app that's running in a heavy PWS container.
Yeah.
Doing its thing, and the PWS team the PCF team makes an upgrade. Does an upgrade to that container based on the platform that goes from version 1.4 to 1.5. Is that something that I as a developer need to keep track of? So if
No.
that breaks, is that going to break my app?
No. So the upgrades will not really upgrade your container. Right? The container, you should really think about these containers as totally ephemeral things, right? It's like a process that happens to be running your app now, but you should treat it as something that can be just blown away at any time and have a new copy of it running somewhere else. So all you care about is your application. You really almost don't even care about the container. You care about your application and the fact that it's running. It happens to be running in a container. Now, when the PWS team or the CloudOps team does any sort of change that involves recreating that virtual machine that it's running inside or any sort of updates to the platform will automatically just delete that container, delete the machine, delete whatever it needs to. It'll start it somewhere else. You don't have to keep track of those updates. So most of the updates that happen don't require any changes on your part. If there is something like there's a new change to the platform and your CLI command line tool is no longer, the older versions are no longer compatible with the new platform. So you won't be able to CF target PWS anymore unless you upgrade the CLI. Then there'll be an announcement sent out and you'll have to do something. If maybe once, a couple times a year, there might be a case where there's something that you do have to do something. And then you'll do the thing, but for most of the time you don't have to keep track of it yourself. Right? There might be something such as like, oh, your current app that's running is running with a version of Ruby that is no longer supported by the Ruby community. If you don't take any action in X amount of time, the new stuff will roll through, and your app will be we'll try to run your app on the new Ruby. It may or may not work, so you might want to proactively, upgrade it to work with the latest Ruby, but we'll give you like lead time to deal with that. Yeah. Cool. All right, so moving on. Fault tolerance. Fault tolerance is the idea that my app can fail and the platform will heal it. So like I talked about, if one of your instances of your app is crashing, the platform won't send traffic to it. It'll also detect that it's crashing and try to restart it somewhere else. You don't have to worry about it. It just heals it for you. Fault tolerance part 2. The whole platform can be failing, and Bosch will heal it. And this is a major, major difference between what Pivotal offers and what a lot of other, especially non-Cloud Foundry platforms offer. They say, maybe you can push your app and maybe we'll heal it for you, but our platform itself, you're on your own. You're SOL if it's not working and if it's going down. Whereas that doesn't fly in the way we build things. Multi-tenancy. I always think about the Mitch Hedberg joke when I think about this. Multi-tenancy is for when you love dev teams and you've got 2,000 of something. If you don't know what I'm talking about, just look up Mitch Hedberg Rice. It's a great joke. Anyways, rest in peace. So yeah, multi-tenancy, if you've got tons and tons of app developers, how do you keep them from colliding and using each other's resources, and how do you just keep all that stuff straight and make sure that this team can't push to that team's production app and take it down and all those sorts of things? You get this for free, and we have a very rich, robust set of features around user authentication. That's pretty advanced. Do you have a question? Oh no, sorry. All right. So that's the end of my list of features that you get out of a platform like Cloud Foundry. I'll ask questions. I'll ask 4 questions in a second. Just had a couple more slides to go. So I have a glossary here consisting of the sort of acronyms that you might see and that I brought up in the talk, and so you can always look at this and figure out, what is PCF, what is PWS-E, what should I be trying to sell somebody? These are what these terms mean. There's a ton of resources, so I think I skipped a step in my origin story of why I did this talk. So it started with talking to some labs pivots who were kind of struggling to explain and sort of argue intelligently about why PCF versus sort of another solution that a customer might use. And this has led to like a whole bunch of other things that we've had. I did a survey and I sent it out to everyone in labs, and I gathered a bunch of sort of information from people about what do they find their clients are using, what do you feel you know well, what do you feel you don't know well. And one of the big things that people said in the like free-form comments is they want a non-technical primer, so that's kind of where this came from. Another big thing that came up is like I don't even know where to find information. Like I have questions, but where do I even go to get answers? So this is just a compilation of a whole bunch of places you can go to try to get answers. I started a Slack channel in the Pivotal Slack, Labs PCF, so you're always welcome to go ask questions there. The open source Cloud Foundry Slack is a good place to go. You can start with the general channel, but there's all sorts of very specific channels you can go to. There's Pivot Talk, of course, and a lot of the discussions around this stuff have sort of sprung up on Pivot Talk itself. So that's a good place to talk about labs and PCF, or just generally like ask questions about CF and PCF and all these sorts of things. Open up GitHub issues if you find things that like aren't clear, aren't working. Open up GitHub issues. I'm not going to go over all these, but there's Pivotal Academy. You can email the PMs. We're always happy to get feedback. There's a bunch of Stack Overflow tags that are fairly active you can ask on. There's mailing lists if you like that. And there's a lot of documentation. I think a lot of people sort of miss the docs, but they're there and they have a lot of good information in them. So check out the documentation. Does anybody have any questions? Yeah.
Does Tracker run on Cloud Foundry?
Tracker, I believe, does run on Cloud Foundry.
Again, Tracker is migrating to Cloud Foundry right now, so there is what the progress.
The question was, does Tracker run on Cloud Foundry? Tushar from the Cloud Ops team confirmed that they're currently migrating to that. Yeah.
Are we, so other companies like Amazon and Google and kind of the infrastructure as a service stuff, are we worried that they're going to just massively flow into platform as a service?
That's a really good question. So the question was, Amazon and Google are doing this infrastructure as a service stuff. Are we worried that they, as competitors, are going to flow into start doing the platform as a service stuff? So if you look at the sort of conversations we're having right now with Azure and Google, they could not be more thrilled to get Pivotal Cloud Foundry on their platforms, on their infrastructures, in their marketplace. They don't want, they realize that you can't just build a platform. I mean, you can, but it's like requires a big team of people working on it for many years. So, the people from Google are coming here pairing with us, and we're chatting with them on Slack on a constant basis. I was at a conference, and one guy from Google gave a talk, and he had the Cloud Foundry shirt the whole time. So they are super excited about using PCF, the platform, as a way to sort of drive business to their infrastructure, and they're not trying to get into the platform space so much. That's kind of the Google Azure story. Amazon is a little bit different, quite a bit different. They're not as eager to play nice, and they have their own offerings of something like a platform. It's not an apples to apples competition. I don't think their sort of answer to platform is something that anybody cares about. But there are a lot of people who think that, well, maybe I don't even need a platform. Maybe I'll just use raw AWS. Maybe I won't use containers. I'll just use Amazon virtual machines. And Amazon, I actually like AWS quite a lot, and they have so many services that are so well integrated with their compute and their storage and their DNS, and all these things are so well integrated that it might make sense for a lot of might make sense for certain organizations to try to go straight to AWS. But then there are reasons you don't want to do that. You don't want to get locked into AWS. That's one of the biggest fears. if you're, if you're a large retailer, for instance, you don't necessarily want to be giving Amazon money because they're one of your biggest competitors often, right? So that's actually a very big reason why a lot of our customers are excited about getting PCF on Azure and Google, because they don't want to be on Amazon because they don't want to give their competitor all that money. So, I think Amazon is competition. I don't think it's like I don't see it as like a threat to fear, but it is a competition that's something to keep sort of fighting against. Yeah. Any other questions? Yeah.
Cloud Foundry is open source. Do you know what license is open source?
I should. Because yeah.
Yeah, it's Apache 2.
Apache 2. This is like where my eyes glaze over every time. Oh, sorry. The question was, what's the licensing on open source Cloud Foundry? It's Apache 2. I know I've seen this multiple times today, like the little thing in the top right of GitHub, what the license was, but it's a blind spot in my eye. Any other questions? No? All right. Thank you very much.